The sweltering heat of summer transforms your vehicle into an unbearable oven, yet the air conditioning system that should provide relief barely manages to produce lukewarm air. This frustrating scenario plays out for millions of drivers who assume their cooling systems require expensive repairs or complete replacement. The reality often proves far simpler and more economical than anticipated. Most automotive climate control problems stem from basic maintenance oversights rather than catastrophic failures. Understanding how your vehicle's cooling system operates reveals why simple adjustments can produce dramatic improvements in performance. The air conditioning mechanism relies on precise pressure differentials, unobstructed airflow pathways, and properly maintained components working in harmony. When any element in this chain experiences degradation or blockage, the entire system suffers reduced efficiency. The encouraging news is that restoring optimal function rarely requires professional intervention or significant financial investment. The journey toward Arctic-level cooling begins with examining the most overlooked component in your climate control system. Hidden behind your dashboard lies a rectangular filter that few drivers know exists, yet it determines the quality and volume of air entering your cabin. This cabin air filtration element serves as the lungs of your ventilation system, screening out pollutants, allergens, and debris before they reach you. Over time, this protective barrier becomes saturated with contaminants, transforming from helper to hindrance. A filter clogged with accumulated dust, pollen, leaves, and insect remains creates substantial resistance to airflow. Your blower motor must work harder to push air through this dense barrier, resulting in reduced velocity at the vents and diminished cooling capacity. Laboratory testing demonstrates that a severely contaminated filter can restrict airflow by 30% or more, effectively neutering your air conditioning performance regardless of how well other components function. Replacing this inexpensive component requires minimal time and no specialized tools. Most vehicles position the filter behind the glove compartment or beneath the windshield cowling, accessible with basic hand tools. The immediate improvement in airflow, velocity, and cooling efficiency after installation often surprises drivers who have tolerated weak performance for months or years. Manufacturers typically recommend replacement intervals between 12 and 15,000 miles, though dusty environments may necessitate more frequent changes. Beyond mechanical components, the sequence of actions when entering a superheated vehicle profoundly impacts cooling efficiency. The instinctive response of immediately activating maximum air conditioning while sealed inside actually prolongs discomfort. Solar radiation can elevate interior temperatures to 140 degrees or higher within 30 minutes of parking. This trapped heat creates a thermal mass that your cooling system must overcome before providing relief. The optimal approach involves strategic heat evacuation before engaging the air conditioning. Opening all windows for 30 to 60 seconds allows natural convection to expel the hottest air rapidly. This simple action can reduce cabin temperature by 20 to 30 degrees, almost instantaneously, dramatically reducing the thermal load your air conditioning must address. Testing confirms this method can accelerate the time to comfortable temperature by 25 to 40% compared to immediate air conditioning activation. The circulation control settings on your climate system represent another frequently misunderstood aspect of efficient cooling. That button, displaying a vehicle with a curved arrow, controls whether your system draws fresh outside air or recirculates cabin air. Using this feature incorrectly can sabotage cooling performance regardless of other factors. Initial startup in a superheated vehicle demands fresh air mode for the first few minutes. Attempting to recirculate extremely hot cabin air forces your system to repeatedly cool the same superheated mass, significantly slowing temperature reduction. Research indicates that proper fresh air flushing during the initial cooling phase can reduce the time to comfortable temperature by 40% compared to immediate recirculation. Once the cabin reaches moderate temperature, switching to recirculation mode becomes essential for maintaining efficiency. This setting prevents your system from continuously cooling hot outside air, instead reprocessing already cooled cabin air. Engineering studies demonstrate that proper recirculation use can improve cooling efficiency by 20 to 30% while reducing compressor workload. Some vehicles can achieve cabin temperatures as low as 40 degrees when recirculation is employed correctly. Fan speed management represents another counterintuitive aspect of maximizing cooling performance. The assumption that maximum fan speed always produces coldest air proves incorrect once initial cooling is achieved. After reducing cabin temperature to reasonable levels, decreasing fan speed actually enhances the cooling sensation at the vents. This phenomenon occurs because slower airflow allows more contact time between the air and the evaporator coil, enabling greater heat transfer. Temperature measurements confirm that medium or low fan speeds can produce air that feels 3 to 6 degrees cooler than high-speed operation. This technique not only improves comfort, but also reduces noise and potentially extends component lifespan through reduced stress. Environmental factors significantly impact your cooling system performance before you even start the engine. Direct sunlight exposure can transform your vehicle into a solar collector, absorbing radiant energy that overwhelms air conditioning capacity. Parking strategies that minimize heat accumulation prove more effective than any mechanical adjustment. Seeking shaded parking whenever possible prevents the extreme temperature buildup that challenges your cooling system. When shade is unavailable, positioning your vehicle to minimize windshield exposure to direct sunlight helps considerably. Reflective windshield barriers can reduce interior temperature by 20 to 40 degrees, according to independent testing, dramatically reducing the cooling deficit your system must overcome. The refrigerant circulating through your air conditioning system serves as the lifeblood of cooling performance. This specialized fluid undergoes phase changes that absorb and release heat, creating the temperature differential that cools your cabin. Even minor refrigerant loss significantly impacts system efficiency, yet many drivers remain unaware of gradual depletion. A system operating with refrigerant levels just 10 to 15% below specification can experience 40% reduction in cooling capacity. The compressor struggles to maintain proper pressure differentials, while the evaporator cannot absorb heat effectively. Monitoring refrigerant pressure with appropriate gauges reveals whether your system requires replenishment. Restoring proper refrigerant levels often produces dramatic improvement, returning performance to factory specifications. The condenser component located at the front of your vehicle plays a critical but often forgotten role in cooling efficiency. This radiator-like structure releases heat absorbed from your cabin into the outside air. When road debris, insects, leaves, and dirt accumulate on the condenser fins, heat transfer efficiency plummets. A contaminated condenser forces refrigerant to remain at elevated temperature, reducing its capacity to absorb heat when returning to the evaporator. Cleaning this component with gentle water spray can restore 25% or more cooling capacity, particularly for vehicles operated in dusty conditions. Care must be taken to avoid damaging the delicate aluminum fins during cleaning. Using only low-pressure water applied at appropriate angles. Regular professional maintenance prevents minor issues from evolving into expensive failures. Components like compressor clutches, expansion valves, and blower motors experience gradual wear that reduces performance incrementally. Evaporator coils can develop mold growth in humid climates, reducing efficiency while potentially causing unpleasant odors. Annual system inspection identifies developing problems before they cause complete failure. Addressing issues like weak compressor engagement or restricted expansion valves can restore 30 to 50% of lost cooling capacity. The investment in preventive maintenance proves far more economical than emergency repairs. During peak summer heat, when demand for service peaks, window treatments offer passive assistance to your active cooling system. Professional-grade window films can reject 60% of solar heat while blocking virtually all harmful ultraviolet radiation. This reduction in thermal load means your air conditioning system works less strenuously to maintain comfortable temperatures. Vehicles with quality window tinting demonstrate measurably lower interior temperatures when parked, sometimes 15 to 25 degrees cooler than untreated vehicles. The reduced solar gain also means faster cooling when the air conditioning engages, reaching comfortable temperature more quickly while consuming less fuel. This modification represents one of the most effective long-term investments for improving climate control performance. The air intake location for your ventilation system requires periodic attention to maintain optimal performance. This often hidden inlet, typically located near the windshield base, can accumulate leaves, twigs, and debris that restrict airflow into your climate control system. A blocked inlet forces your blower motor to work harder, while delivering less air to the cabin. Clearing accumulated debris from this area using compressed air or gentle vacuum suction can improve system performance by 15% or more. This maintenance task becomes particularly important during autumn, when falling leaves accumulate rapidly, or after dust storms that deposit fine particles in every crevice. Understanding the thermodynamic principles governing automotive cooling helps optimize system use. Your air conditioning does not actually create cold, but rather removes heat from the cabin air. This heat extraction process requires energy, typically consuming 5 to 20 horsepower depending on cooling demand. Minimizing unnecessary heat sources reduces the burden on your cooling system. Keeping windows closed during operation prevents cooled air escape and hot air infiltration. Dark interior surfaces absorb more solar radiation than light colors, increasing cooling requirements. Windshield sunshades when parked prevent dashboard heating that continues radiating warmth long after sunset. Each small improvement compounds to create noticeable enhancement in cooling performance. The relationship between vehicle speed and cooling efficiency deserves consideration. At idle or low speeds, reduced airflow through the condenser diminishes heat rejection capacity. Highway speeds provide maximum condenser cooling, explaining why your air conditioning often feels more effective during highway cruising than city driving. When stuck in traffic during extreme heat, slightly increasing idle speed can improve condenser airflow and cooling performance. Some vehicles automatically increase idle speed when air conditioning is engaged. For this reason, understanding these relationships helps set realistic expectations and adjust usage patterns for optimal comfort. Refrigerant type matters more than many drivers realize. Older vehicles designed for R12 refrigerant converted to R134A often exhibit reduced cooling capacity due to thermodynamic differences between these compounds. Newer vehicles using R1234YF refrigerant may require specific service procedures and equipment unfamiliar to some technicians. Using incorrect refrigerant or mixing types can damage components and violate environmental regulations. Professional service ensures proper refrigerant type and quantity, maximizing cooling performance while maintaining system integrity. Documentation of refrigerant type and service history proves valuable for future maintenance and potential vehicle sale. The compressor clutch mechanism deserves special attention as the heart of your cooling system. This electromagnetic device engages and disengages the compressor based on system demands. A slipping or failing clutch prevents proper refrigerant compression, resulting in inadequate cooling despite other components functioning correctly. Symptoms of clutch problems include intermittent cooling, unusual noises, or visible clutch slippage. Early intervention often involves simple adjustment or cleaning, while delayed attention may necessitate complete compressor replacement. Regular observation of clutch operation during routine maintenance can identify developing issues before they cause system failure. The evaporator drainage represents an often overlooked maintenance requirement. As warm air passes over the cold evaporator, moisture condenses and must drain from the system. A clogged drain tube causes water accumulation that reduces cooling efficiency and potentially causes interior water damage. Symptoms include reduced cooling performance, musty odors, or water appearing on passenger floor mats. Clearing the drain tube, typically located beneath the vehicle near the firewall, restores proper drainage and cooling efficiency. This simple maintenance task prevents expensive repairs and maintains system performance. Belt tension affects compressor operation more than many realize. A loose or worn drive belt cannot properly rotate the compressor, reducing refrigerant circulation and cooling capacity. Modern serpentine belts may appear adequate while actually slipping under load, particularly when aged or contaminated with oil. Regular belt inspection during oil changes identifies where before failure occurs. Proper tension ensures maximum compressor efficiency while preventing premature bearing, where replacement costs remain minimal compared to consequential damage from belt failure during operation. System pressure monitoring provides valuable diagnostic information about cooling performance. Both high and low side pressures must fall within specified ranges for optimal operation. Deviations indicate specific problems requiring attention. Excessive high side pressure suggests condenser blockage or overcharge, while low readings indicate refrigerant loss or compressor weakness. Low side pressure abnormalities reveal evaporator restrictions or expansion valve malfunctions. Professional pressure testing during annual service identifies developing issues before they impact comfort or cause component damage. The electrical systems supporting your air conditioning deserve consideration. Blower motor resistors control fan speeds, and failure causes loss of certain speed settings. Relay problems prevent compressor engagement despite adequate control module issues create erratic operation or complete system failure. These electrical components often fail gradually, providing warning signs before complete failure. Addressing electrical issues promptly prevents secondary damage and maintains consistent cooling performance. Modern vehicles may require specialized diagnostic equipment to identify electronic control problems. Proper refrigerant oil maintenance ensures compressor longevity and system efficiency. This specialized lubricant circulates with refrigerant, lubricating compressor components and sealing microscopic gaps. Oil degradation or loss causes premature wear and reduced cooling capacity. During refrigerant service, technicians should verify oil quantity and condition. Contaminated oil appears dark or contains metallic particles indicating component wear. Fresh oil maintains proper viscosity and lubrication properties, extending component life while maintaining cooling performance. Temperature sensor calibration affects system operation more than apparent. These sensors inform the control module about evaporator temperature, cabin temperature, and ambient conditions. Inaccurate readings cause improper system cycling, reduced efficiency, or inadequate cooling. Sensor testing during routine service identifies calibration drift before it impacts comfort. Replacement sensors remain inexpensive compared to the frustration of inadequate cooling during summer heat. Proper sensor function ensures your system responds appropriately to changing conditions. Understanding seasonal variations helps optimize year-round performance. Winter operation circulates refrigerant oil, preventing seal degradation during extended dormancy. Monthly winter operation for several minutes maintains component lubrication and prevents moisture accumulation that causes corrosion. Spring preparation includes cleaning condensers of winter debris, checking refrigerant pressure, and testing system operation before summer heat arrives. This proactive approach identifies issues when service availability remains high and prices moderate. Waiting until peak summer often means extended wait times and premium service costs. Cabin air quality impacts perceived cooling effectiveness. Stale, humid air feels warmer than fresh, dry air at identical temperatures. Your ventilation system should provide comfortable temperature while maintaining pleasant air quality through appropriate filtration and circulation. Advanced filtration options include activated carbon elements that remove odors and gases. Standard filters, HEPA-grade filters, capture smaller particles, improving air quality for sensitive individuals. These upgrades enhance comfort beyond simple temperature control, creating a more pleasant driving environment. The integration between your air conditioning and heating systems affects overall climate control performance. Blend doors that direct air through heating or cooling cores must operate smoothly for proper temperature regulation. Stuck or damaged blend doors cause inadequate cooling despite properly functioning air conditioning components. Symptoms include inability to achieve maximum cooling or unwanted warm air mixing. Blend door repair ranges from simple actuator replacement to dashboard removal for mechanical door access. Early attention to temperature control irregularities prevents complete failure during extreme weather. Acoustic considerations influence perceived cooling comfort. Excessive blower noise creates stress that amplifies heat perception. Worn bearings, damaged fan blades, or restricted airways generate unwanted noise that diminishes driving pleasure. Addressing noise sources improves comfort beyond simple temperature reduction. Balanced fan assemblies, properly lubricated bearings, and clear airways create quiet operation that enhances the cooling experience. The psychological impact of quiet, efficient operation should not be underestimated. Energy efficiency considerations become increasingly important with rising fuel costs. Your air conditioning system represents one of the largest auxiliary power consumers in your vehicle. Optimizing operation reduces fuel consumption while maintaining comfort. Strategies include gradual temperature reduction rather than maximum cooling, using recirculation mode appropriately, and combining ventilation with air conditioning during moderate conditions. Park ventilation while stationary reduces initial cooling requirements. These techniques can reduce fuel consumption by 10 to 15% during summer months. Future developments in automotive climate control promise improved efficiency and comfort. Electric vehicles utilize heat pumps that provide heating and cooling more efficiently than traditional systems. Variable displacement compressors adjust capacity based on demand, reducing energy consumption. Advanced filtration systems may soon eliminate viruses and ultrafine particles. Understanding current technology while anticipating future developments helps make informed maintenance and upgrade decisions. Investment in quality maintenance today ensures your system continues providing reliable comfort regardless of outside conditions. The knowledge that simple attention to basic maintenance can transform weak cooling into Arctic performance empowers drivers to take control of their comfort. Without dependence on expensive professional intervention, the combination of proper maintenance, correct operation procedures, and strategic modifications creates a cooling system that performs beyond original specifications. Each individual improvement compounds with others, creating cumulative enhancement that transforms summer driving from endurance test to comfortable journey. The minimal investment in filters, cleaning supplies, and basic maintenance yields returns measured in years of reliable cooling performance. Your vehicle's air conditioning system stands ready to provide exceptional cooling performance when properly maintained and operated. The barriers to achieving archetypical of all cooling are not mechanical limitations, but rather knowledge gaps about proper care and use. Armed with understanding of these principles, any driver can optimize their climate control system for maximum comfort with minimal expense, ensuring pleasant driving regardless of external temperature extremes.